So take a look at this problem. It says find a parametric equation that defines the curve. So even though this is a straight line, it is a curve. And notice this is a line segment and it goes from here to here. And it also is in this direction. So when we create our parametric equations, they have to be that way. Now, essentially what we can do first is we could just find the equation of a line and start that way if we'd like to. And the way we can do that is, do you guys remember how that works? First I find the slope, so I got to find m. So it's my change in y, so it'll be 5 minus 0 over 7 minus 2. So this is going to be 5 over 5, which equals 1. Okay, which we could have just did rise over run, couldn't we? So it goes up 1 over 1, up 1 over 1. Then I could have got the m straight away without using algebra, just by the picture. So now, what we can do from here is we need a point. So my general formula of a line is y equals mx plus b. And my m is 1, so really I have y equals 1x, or I would just write x plus b. And then I can just plug in any one of my points there. So I'm going to plug in 2, 0 because it has a 0 in it. So 0 equals 2 plus b. So then this tells me b equals negative 2. So my equation then is going to be y equals x minus 2. And that's the equation of that line. So if I wanted to talk about the parametric equations, when I'm given an equation, it's a whole lot easier because I can simply say that let x equal t. Then what is my y going to be? So then my y is going to equal t minus 2. Done. And this is one thing I can mostly do all the time. I can just say x is this letter. Or I can get a little fancy, and let's say we want to say that x is equal to t minus 1. Okay, then what is y going to be? So I can simply think of that y being, so I'm just going to plug in for x, the t minus 1, and then I have minus 2, right? And I'm going back to the original equation up here, just so you know. And that's the one I plugged it into, because that was the equation we came up with. So then, that's going to be y equals t minus 3. So that's what this one is going to be. So that is a way to come up with a few, right? So let me organize these the right way. So this was one of my answers, because I need those two together, and this was another answer. So there I have two separate answers that both result in the same thing, almost. I'm missing one component here. Now notice this is a line segment, and it starts here and ends here. So now with my equations I have, they don't end there. These go on forever. They go all the way to negative infinity to positive infinity. So I'm going to have to fix that. So I'm going to put my parameter on these. So now, let's see what that means. So I look at for my x. My x is starting at 2, which is here. So when my t is 2, that's where I'm starting at 2. And when I plug it in for my y, I'm going to get 0. So my t is going to start at 2. And then my t is going to end at 7. And because they're equal, it's just going to be that bound for my parameters for t. So that is actually my answer for this first one here. Don't forget your parameters. A lot of times people forget their parameters here, and they'll lose points for that. So be careful. So here's the other one. So I got x equals t minus 1, and my y equals t minus 3. And then if I plug in my t here, where's my t going to start at? So then my t could be, it has to be 2 there. So that means if I plug in a 3 here, I'm going to get a 2. So then my t would start at 3. And it's going to go all the way up to, now remember my n value needs to, for my x, needs to be a 7. So that means this is going to go to 10 then, isn't it? Yeah, because 10 minus 3 is 7. Essentially what I can do, oops, I'm sorry, wrong one. I'm here. So when I look at this one, what does this one have to be a 7? So that would have to be an 8. So that would run from 3 to 8, not 10. I apologize. That was a y value. And I wasn't looking for y values. I was looking for my x values. Now again, we can check to see if that's going to work then. So when I plug that 8 in there, I am going to get my 7. So let's try it in for the y value. So when I plug in a 3, I get 0, right? Here. Okay, we can see that when I plug in an 8, I do get my 5. So these are my other parameters. Now I don't have to check the y values. Because of the way it's set up, it'll always work. It's very nice though, I just wanted to show that to you. So these would be two separate parametric equations that define the curve. So that was pretty easy, right? Now one thing to keep in mind though, that there's a lot of different possibilities here. I just gave you two and I just, in a sense, pulled them out of thin air. But with these linears and some of these quadratics and stuff, it's nicer just to pick x equals t. Just something to keep in mind.